Hey everyone, today we are going to solve the Daily LeetCode challenge of 16th March 2024, and the problem statement is continuous array. So let us first understand the problem statement. So according to the problem statement, we have been given a binary integer array nums. So it means that it contains only ones and zeros, and it won't contain any other digit except 1 or 0, okay? And what we have to do is we have to find the maximum length of subarray that contains equal number of 0 and 1s. Equal 0 and 1s. Okay. Now, what do I mean by subarray? So a subarray is a continuous part of an array. Okay. So if I'll say that, is this 0, 1 a subarray? So the answer is yes. Why? Because it is a continuous part of an array. Okay. Now if I'll ask, is this 1, 1 a subarray? So the answer would be no. Why? Because it is not continuous. You can see that we are missing an element in between. Correct. So this is not a subarray. Whenever we have a subarray, it means that it is a continuous part. That is, we don't miss out any elements in between. Okay. Now let's see how we can solve this problem. So for solving this problem, I'll be discussing two approaches. Now let us first discuss the approach one. So let's say this is the given array to us. And what we will do in approach one is we will find out all the possible subarrays. Find out all the possible subarrays. And after that, what we will do? We will count the number of zeros and ones. And if they are equal, what we will do? If they are equal, we will find out the max length. Equal, find max length. Okay. So let us quickly write all the possible subarrays for this given array. So if we will start from 0, so we'll have a 0, we'll have 0, 1, we'll have 0, 1, 0, then we'll have 0, 1, 0, 1. Now if we start from this one, we will have a 1, we will have 1, 0, we'll have 1, 0, 1. Now when we will start from this 0, we'll have a 0, we'll have 0, 1. Now we are only left with this one, so we'll have only this one. So we are done with the first step, that is find out all the possible subarrays. Okay. Now what is the second step? The second step is to count the number of zeros and 1. Okay. And after that, if they are equal, we are going to find out the max length. So let us find out that which all subarrays are having equal number of zeros and 1. So here we can see that it's only having 1 0. Okay, so it means it's not having equal number of zeros and 1. So let's cancel this one. Is this one having equal number of 0 and 1? So we can see it's having 1 0 and 1 1. So it's having equal number of zeros and 1. And what's its length? Its length is 2. Now here we don't have equal number of zeros and 1 because the 0 count is 2 and the 1 count is only 1. So we will cancel this one as well. Here we can see the count of 0 is 2 and the count of 1 is also 2. It means that they are having equal number of zeros and 1. So what is its length? Its length is 4. Now this one is not having equal number of zeros and 1. So let's cancel this. This one is having equal number of zeros and 1. So let's find its length. It's 2. Here we can see that we are having 2, 1 and only 1, 0. So it means that it's not having equal number of 0 and 1. So let's cancel this one. Here also we are not having equal number of zeros and 1. This one is having equal number of zeros and 1 and the length is 2. This one is not having equal number of zeros and 1. Now that we have found out that what are the subarrays that has equal number of zeros and 1, now what do we need to do? We need to find the max length. So what is the max of this 2, 4, 2, 2? The max is 4, correct? So the answer to this example would be 4. Additionally, you can see that which subarray has the maximum length and it also has equal number of zeros and 1. It's this one, the entire array. You can see that how many zeros we have. We have 2 zeros, and how many ones we have? We have 2 ones. So it means that it's having equal number of zeros and 1, correct? Now the question is, how do we actually implement this? So let's see. So as you all saw that firstly what we are doing, we are iterating over all these elements, correct? Like here we started from 0, then we started from 1, then we started from this 0, then we started from this one. So it means that we will have a for loop. Let's say the pointer is I and it will go from 0 to n, correct? That is, it will help us to iterate over all the elements. Additionally, what you saw is, say for example, if I'm present at this 0, then what I was doing? I was finding the length from this 0 to 0, then I included the element from 0 to 1, then I included the element from 0 to 0, then I included the element from this 0 to this one, that is this one, correct? That's how we got these array, right? So it means that inside this, we will have another for loop. Say for example, we have j and it will start from which one? Say for example, when I was present at this one, then what we were doing? Were we including this 0? No, we weren't including this 0. We included this 1 which is here. Then after that, what we did? We included this one and this 0, which is this one. Then we included this one, this 0, and this one. That is this one, correct? So it means that it will start from the ith index and it will go up till n, right? Now, one more thing we have to do is we have to keep track of the count of 0 and 1. Let's say we have two variables, 0, which would be initially 0, and another variable 1, which would also be initially 0. Now, why are we using these two variables? These two variables we are using to keep track of the count of 0 and 1 that we have got till now. Now, what we will do, if we will get that the value present at the jth index, say for nums of j, is equals to 0. In that case, what we will do? In that case, we will increment the 0 count. Otherwise, what we will do? Otherwise, it means that the element present at nums of j is 1. So we will simply increment the 1's count. Correct? Now, after that, we'll check that if 0 count is equal to 1 count, then what does it mean? It means that we have got a subarray that has equal number of 0 and 1. And what do we have to do? We just simply have to say, for example, if we take a variable as max length, which would be initially 0. Now, what does this max length represent? We are using this max length to keep track of the max length of the subarray that has equal number of zeros and 1. So at that time, what we will do? We will set max length as the maximum of the previous max length which we had, which is this 0, which would be initially 0, correct? And j minus I plus 1, correct? Why j minus I plus 1? Let's say that our ith pointer is over here and our jth pointer is over here. And we can notice that in this subarray, we are having equal number of zeros and 1, right? We are having 1, 1 and 1, 0. And what is the length? The length is 2. How are we getting this length? It would be j minus I plus 1. What is j? If we index them 0, 1, 2. So j is 2 minus I. What is I? I is 1 plus 1. So what are we getting as length? 2. Correct. That's why we have written j minus I plus 1. So let's do a quick dry run for this given example. So initially max length would be 0. Our ith pointer will point at the 0th index. So our I will be equal to 0. And our jth pointer will also start from I, right? So initially the value of the jth pointer will also be 0. So jth pointer is over here, correct? Now what we have to do, we'll check that what is the value present at our jth pointer. So the value present at our jth pointer is 0. So what we will do, we will increment the 0th count. Now what we will check? We'll check, is the 0 count and 1 count equal? No, they are not equal. So what we'll do, we'll simply move the jth pointer. So the jth pointer is now pointing over here. Now, what is the value present at the jth pointer? It's 1. So what we'll do, we will increment 1 count. Okay. Now after incrementing 1 count, what we'll do, we will check if the 0 count and 1 count are equal. So we can see that the 0 count and 1 count are equal. So what we will do, we will find out max length. That is, we'll update max length. So we will say that max length is max of max length, comma j minus I plus 1. So what is max length? Max length is 0. So what it would be? It would be the maximum of 0, comma. Where is j pointer? J pointer is at index 1. What is I? I is pointing at index 0. So 1 minus 0 plus 1. So what would be the length? The length would be 2. So we will have the maximum of 0, comma 2, which is 2. So max length will get updated to 2. Now what does it mean? It means that we have got a subarray that has equal number of zeros and 1. And which one is that subarray? This is that subarray. You can see that we have equal number of zeros and 1. Okay, now what we'll do? Now the value of jth pointer will get incremented to 2. So jth pointer will now point over here. Now the value present at our jth pointer is 0. So what we'll do? We will increment the 0 count. Now we'll check. Are these two values equal? No, they are not equal. So again, the value of the jth pointer will get incremented to 3. So jth pointer will now be pointing at here. So we'll check that the value present at our jth pointer is 1. Correct? So what we'll do? We will increment the 1 count. So it will become 2. Now we will check that the count of 0 and the count of 1 are equal. So what we will do? Again, we will update max length. Okay. So what would be max length? Max length would be the max of max length. What is max length? Max length is 2, comma j minus I plus 1. Where is our jth pointer? It's at index 3. Where is our ith pointer? It's at index 0. So 3 minus 0 plus 1, it will give us 4. So what would be the max of 2, comma 4? It would be 4, correct? So our max length will get updated to 4. Now again the value of jth pointer will get updated to 4. So the jth pointer will point over here. So it means that we have found out all the possible subarrays starting from index 0. Now what will happen? Now the ith pointer will get updated to 1. So we will have I as 1. And the value of 0 count and 1 count will again get initialized to 0. And where would be our jth pointer? Our jth pointer will start from I, correct? So where is I? I is at the index 1. So we will have j pointer over here. Okay. So what would be the initial value of jth pointer? It would be 1. So what is the value present at the jth pointer? It's 1. So what we will do? We will increment the count of 1. Now we will check, is this 0 count and 1 count equal? No, they are not equal. So what we'll do? We will move the jth pointer forward. Now we have got a 0. So what we'll do? We will increment the 0 count. Now we'll check, what are these two values equal? So these two values are equal. So what we'll do? We will find the max of max length comma j minus I plus 1. Now what is max length? Max length is 4. Now where is j? J is at index 2. So we will have 2 minus, where is I? I is at index 1. 1 plus 1. So what we'll get? We'll get 4 comma 2. So what is the max of 4 comma 2? The max of 4 comma 2 is 4 only. So this max length will not get updated. Okay. Now what we'll do? We'll move the jth pointer. So it will point at index 3. Now what is the value present at the index 3? It's 1. Correct? So what we will do? We will increment the 1 counter. Now we will check, are these two values equal? So these two values are not equal. So what we will do? We'll simply increment the jth pointer. So the value of j will become 4. Now since we can see that there are no more elements, so what will happen? The ith pointer will now move forward. So the ith pointer will be now pointing at index 2. And the value of 0 and 1 counter will get reinitialized to 0. And where would be our jth pointer? Our jth pointer will now point at I. So where is I? I is at index 2. So j will also be at index 2. Okay. So now, what is the value present at the jth pointer? It's 0. So what we'll do? We will increment the 0 count. Now we will check, are these two values equal? So these two values are not equal. So what we'll do? We'll simply move the jth pointer forward. So it will become equal to 3. Now what is the value present at our jth pointer? It's 1. Correct? So we will increment the 1 count. Now we will check, are these two values equal? So these two values are equal. So what we'll do? We will check that whether we can update max length or not. So what is the value of max length? It's 4. And where is our jth pointer? It's at index 3. So we'll have 3 minus, where is I? I is at 2. 2 plus 1. So what this would be? This would be nothing but 4 comma 2. Correct? Now what is the max of 4 and 2? It's 4, right? So max length won't get updated. Now we will again move our jth pointer forward. So the value of j will become 4, and we can see that we don't have any more elements left. So what will happen? We will now increment our ith pointer. So our ith pointer will now point at index 3, and the value of 0 count and 1 count will get reinitialized to 0, and our jth pointer will also point at index 3, right? Because our jth pointer is starting from I. So we have I as 3 and j as 3. Now what is the value present at our jth pointer? It's 1, right? So what we'll do? We will increment the 1 count. Now we will check, are these two values equal? So these two values are not equal. So what we'll do? We'll simply increment the jth pointer. So now the value of jth pointer will be 4. Since no more elements exist, so what does it mean? It means that we will now increment our ith pointer, because we have successfully found out all the subarrays starting from this index 3. So we will just increment the ith pointer. Now the value of I is 4. So we can see that no more elements exist. So it means that we are done processing all the elements of nums, right? And what is the max length? The max length is 4. And which subarray is having the max length of 4? It's this one. That is the entire array, right? So we can see it's having equal number of zeros and equal number of 1. So this is how we are going to solve this problem using the first approach. Now talking about its time complexity, so you can see that we are having two loops such that both of them are nested, right? So what would be the time complexity? The time complexity would be order of n square, considering that n is the size of the given array, right? And what would be the space complexity? Because we are not using any extra space from our end, right? So that's why the space complexity would be order of 1. Now if you check the constraint, so you will find out that this solution with the time complexity of order of n square will give us a time limit exceeded error. Okay. Now let's see that can we have another solution that has a better time complexity. So let's quickly discuss the second approach. So let's see how we can solve this problem using the second approach. So say for example, this is the array given to us. So what does this array contains? This array contains only 1 and 0. Okay. Now let's see what would happen if this array would have contained 1 and minus 1 instead of this 0. Correct. So what we would have over here, we would have a minus 1. 1 will remain as it is. Here it's 0. So we would have a minus 1. And this one would be 1 only. Correct. So what we can do is, let's find the prefix sum. Okay. So what would be the prefix sum over here? It would be minus 1. Let me write prefix sum. Okay. So what is this? This one is the array containing 1 and 0. What is this? This one is the array containing 1 and minus 1, that is we have replaced 0 with minus 1. And what is this? This one is the prefix sum. Okay. So what would be the prefix sum over here? It would be minus 1. What would be the prefix sum over here? It would be minus 1 plus 1, which would be 0. What would be the prefix sum over here? It would be 0 plus minus 1, that is minus 1. What would be the prefix sum over here? It would be minus 1 plus 1, that is 0. Okay. Now, can we find out some pattern over here? So the answer is yes. We can see that this prefix sum minus 1 and this prefix sum minus 1 is repeating itself. And whenever a prefix sum repeat itself, what does it mean? When a prefix sum repeat itself, it means that all the elements in between it, right? All elements in between it is having a sum of 0, correct? So since this prefix sum is repeating itself over here, so what does it mean? It means that all the elements in between it is having a sum of 0, then only it's possible that this prefix sum will repeat itself, correct? Because if the sum of the elements in between it would not have been 0, then what would have happened? Then in that case, either this prefix sum would have got increased to some number, or either it could have got decreased to some number, right? It wouldn't have remained the same. So since it's the same, so what does it mean? It means that the elements in between it is having a sum of 0, correct? Now, my question is that if my array contains only minus 1 and 1, then when is it possible to get a sum equals to 0? When is it possible? It's possible only when we will have equal number of minus 1 and equal number of 1. Then only we can get a sum of 0, correct? Because see, if we have only 1 minus 1 and 2 1, in that case, what would be the sum? The sum would be 1, correct? And if we would have 2 minus 1 and only 1 1, what would be the sum? Minus 1 is minus 2 plus 1 is what? Minus 1. And if we would have 2 minus 1 and if we will have 2 ones, then what would be the sum? Minus 1 is minus 2, 1 plus 1 is 2, then we will have 0 as the sum, correct? So if we have equal number of minus 1 and 1, then only we can get a sum of 0, right? So what did we notice from here? We notice that whenever a prefix sum repeat itself, it means that the elements in between them are having a sum of 0. And since we have an array that contains only minus 1 and 1, then when is it possible to get a sum of 0? It is possible only when the number of 1 and the number of minus 1 are equal, correct? Additionally, we can also notice that this prefix sum 0 is also repeating itself, correct? So what does it mean? It means that the elements in between them are having a sum of 0. So what are those elements? It's these two elements, correct? And what does it mean that they are having a sum of 0? When they have a sum of 0, it means that they have equal number of zeros and 1, correct? Now let's verify this with the actual array, correct? We said that this array should have equal number of 1 and minus 1. They are having equal number of 1 and minus 1. And in case of actual array, they are having equal number of 1 and 0, correct? Now, we said that this array is also having equal number of 1 and minus 1, right? And we can see that in the actual array as well, this subarray is having equal number of 0 and 1, correct? Now, what is the size of this subarray? It's 2. And what is the size of this subarray? It's 2 as well. But what's our answer? Our answer is 4, right? And which subarray is giving us the answer of 4? It's the complete subarray, correct? Now, we are having a problem that the answer should be 4, but we are getting answer as 2. Why? It is because we can have a case in which the answer subarray is the entire subarray which is given to us. So for handling those type of cases, we have to store the initial prefix sum 0. What was our prefix sum initially? It wasn't minus 1, right? It was 0. Initially, our prefix sum was 0. And where were we finding this prefix sum? So we have to store the index as minus 1. Okay. So when did we found out this prefix sum earlier? We didn't find out this prefix sum earlier over here. It was already present at minus 1 index, right? Because initially our prefix sum is minus 1. So what would be the length? The length would be the current index minus this index. So what is the current index? If we will index them, then we will find that the current index is 3 minus this index. What is this index? This index is nothing but minus 1. So what we'll get? We'll get a 4 over here. Okay. So we understood that what we have to do. We have to find out prefix sum. Additionally, we also have to keep track of prefix sum, right? We have to keep track of these prefix sum. Then only we can say that this prefix sum is repeating itself. Because if we will store this prefix sum somewhere, then only we can say that it's repeating itself, right? So where we will store them? We will store them in the hash map. Additionally, we also notice that we can have a situation in which the entire subarray is giving us the max length, right? That is, the entire subarray is having the equal number of zeros and ones. So for handling those type of cases, what we will do is, we will initially store the prefix sum 0 and its corresponding index as -1, right? Now let's quickly do a dry run to understand this better. Let's quickly do a recap of what we discussed. We discussed that we will keep track of this prefix sum in a hash map, correct? And whenever a prefix sum will repeat itself, then what does it mean? It means that all the elements in between them has a sum of 0. Okay. Now, if we have an array that contains -1 and 1, then when can we have a sum of 0? We can have a sum of 0 only when they are equal, correct? Now, one thing to notice is that originally in the array we had 0 and 1. And what we did is we replaced this 0 with this -1. So if we have equal number of -1 and 1, then what does it mean? It simply means that we have equal number of 0 and 1, correct? And whenever we will have equal number of 0 and 1, in that case, what it means? It means that we have got a subarray that has equal number of 0 and 1. So we have to update max length if it is possible to update, correct? Now let's quickly do the dry run. So what we will store in the hash map, we will store the prefix sum, and corresponding to it, we will store the index, correct? Initially, our prefix sum is 0. So we will store 0 and corresponding to it, we will store -1. Why are we storing like this? We are storing like this because we can have a test case in which our entire array is having equal number of 0 and 1. So as to handle that kind of cases, we will be storing this 0 and -1. Okay. Now let's see. Currently our pointer is over here. Let me write it as C. So this is our current. What is the value at current? The value at current is -1. So what we will do? We will add -1 to our prefix sum. Correct. So what we'll get? We'll get -1. Now we'll check that is this prefix sum already present in our hash map? So we don't have this prefix sum already in our hash map. So what we will do? We will add this prefix sum. So we will add -1 and its corresponding index is 0. Okay. Now we will move the current pointer. So the current pointer is now pointing at index 1. What is the element present at index 1? The element present at index 1 is 1. So what we will do? We will simply add a 1 to our prefix sum. So what is our prefix sum? Our prefix sum is now 0. Now we will check that does this prefix sum already exist in our hash map? So we can see that prefix sum 0 already exists in our hash map. So what we will do? We will find out max length. So what would be max length? Max length would be the max of max length, which is 0, comma, the current index. What is the current index? 1 minus the index corresponding to the prefix sum that we have got. And what is it? It's -1. So we will subtract a -1 from here. So what we'll get? We'll get 0, 2. So what is the max of 0, 2? It's 2. So we will write a 2 over here. Now what does this imply? This implies that we have got a subarray that contains equal number of 0 and 1. And what is that subarray? This is that subarray. Correct? Now what we will do? We will move the current pointer. So the current pointer is now pointing at index 2 and the element is 0. So what we will do? We will add a -1 to our prefix sum. What is our prefix sum? Our prefix sum is 0. So we will add a -1 to it and we will get -1. Now we will check. Does this prefix sum already exist in our hash map? So we can see that a prefix sum of -1 already exists in our hash map. So what we will do? We will again find the max length. So what would be max length? Max length would be the max of max length. So max length is 2, comma, current index. What is the current index? Current index is 2 minus the index corresponding to the prefix sum. So what is it? It's 0. So 2 minus 0 gives us 2. So we will get 2, 2. So what is the max of 2, 2? It's 2 only. So max length will remain as it is. Now, since this prefix sum -1 repeated itself, so what did it mean? It means that we have got a subarray that has equal number of 0 and 1. And which subarray is that? It's this one. Correct? Now what will happen? Now the current pointer will get incremented. So current is now pointing at index 3 and the element is 1. So what we will do? We will add a 1 over here. So what we'll get? We'll get prefix sum as 0. Now we'll check. Does this prefix sum already exist? So we can see that this prefix sum already exists. So what we will do? We will again check whether we can update max length or not. So what is max length? Max length would be the max of 2, comma, current index is 3 minus the index corresponding to the repeating prefix sum. So which is the repeating prefix sum? It's 0. And what is the index corresponding to it? It's -1. So we will subtract -1 from here. So minus will be plus. So 3 plus 1 would be 4. So what is the maximum of 2 and 4? It's 4. So max length will get updated to 4. Okay, now the current will again get incremented. So now current is pointing at 4 and index 4 does not exist. So what does it mean? It means that we have successfully processed all the elements of the nums and we have got max length as 4. And which subarray is having this length? It's this entire array, right? It's having equal number of 0 and 1. We are having 2 zeros and we are having 2 ones, right? So this is how we are going to solve this problem using the second approach. Now, I hope it's clear to you all. So let's quickly code it. So we will start on by creating a variable max length, which would be initially 0. We will use this variable to find out the maximum length of the subarray that has equal number of 0 and 1. We'll take another variable prefix sum, which would be initially 0 as well. And let's take an unordered map of int, int. Let's name it as a memo. And what we will store the prefix sum and corresponding index, right? And we discussed that initially we have to store memo of 0 as -1. Why? Because we can have cases in which the entire array itself can have equal number of 0 and 1. So as to handle these type of cases, we'll be storing this one, correct? Why are we storing this one? Because we can have cases like 0, 1, in which the entire array is having equal number of 0 and 1. Now what we have to do, we have to iterate over all the elements. So let's say index equals to 0, index less than nums dot size, index plus plus. Now what we have to check? We have to check that what is the value present at nums of index. Now if the element present at nums of index is 0, then what we were doing? We were adding -1 to our prefix sum, correct? Now what does it mean to add -1 to prefix sum? It means that we were decrementing prefix sum by 1, okay? Else what does it mean? If the value present at nums of index is not 0, then what does it mean? It means that it's 1. So what we'll do? We'll simply add 1 to it. So it means we will increment prefix sum by 1. Now what we have to do? Now we have to check that whether this prefix sum is already present in our hash map or not. Correct. Now if this prefix sum is already present in our hash map, then what does it mean? It means that all the elements in between them is having a sum of 0. Correct. And what does it imply? It implies that we have equal number of -1 and 1. Correct. And when we were adding this -1, we were adding this -1 when we were having 0, right? So it means we have equal number of 0 and 1. So what we have to do, we have to now check whether we can update this max length or not. So let's find out the current length. So current length. So what would be the current length? The current length would be index minus the index at which we found out this prefix sum, correct? So the index at which we have previously found out the prefix sum. Now what we have to do, we have to find the max of max length, comma, current length. Now if this prefix sum didn't exist in our hash map earlier, so what we have to do, we have to add this prefix sum and its corresponding index. Now what we'll do, we'll simply return the max length. So now let's quickly run this. It's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So the time complexity is order of n. Why? Because we are iterating over all the elements of this nums array, right? So it means that we would be traversing over all the n elements. So the time complexity is order of n. Additionally, the space complexity is also order of n. Why? Because we are using a hash map, and in the worst case, all these prefix sum can be distinct. So in that case, we can have all n entries in our hash map, correct? So that's the reason why the space complexity is also order of n. So that's all about today's daily LeetCode challenge. Thank you.